One of the biggest challenges of sending humans to Mars is the entry, descent, and landing of the large, massive equipment that will be needed on the red planet's surface. As witnessed during the descent of NASA's Mars Science Laboratory in 2012, the entry into the Mars atmosphere can be a harrowing experience. They didn't call it the 7 minutes of terror for no reason. NASA's Space Technology Mission Directorate is investing in a suite of EDL technologies that will help the agency meet its goal to get humans to Mars by the mid-2030s. The technologies include hypersonic and supersonic decelerators, a new generation of thermal protection system materials, retro-propulsion technologies, instrumentation, and new modeling capabilities. NASA is advancing the technology of inflatable and mechanically deployable heat shield systems to get larger vehicles with more massive payloads safely through the atmosphere of Mars. Another way to slow descent and land safely on Mars is to use atmospheric drag. Current parachute technology for decelerating from the high speed of atmospheric entry to the final stages of landing on Mars dates back to NASA's Viking program. NASA is expanding that technology through its low-density supersonic decelerator project. In 2014, a rocket-powered, saucer-shaped test vehicle launched off the coast of Hawaii and successfully demonstrated two new landing technologies, a supersonic inflatable aerodynamic decelerator and a supersonic parachute. Another method of landing safely on Mars is using supersonic retropropulsion. This landing maneuver uses retro rockets at supersonic speeds to decelerate the vehicle as it's traveling through the atmosphere. NASA is gathering data from a commercial flight test to learn more about this technology. As important as it is to slow down, it's also important not to burn up. Sophisticated new heat shield material that is woven together on a loom will change the way NASA explores. From the loom, this material can become a part of a rigid heat shield or a part of a stowable covering on a deployable heat shield. The sturdy, heat-resistant material can be tailored to fit different spacecraft and will be flight tested on Orion's compression pads during exploration mission EM-1 in 2017. We got through the atmosphere, but how did we do? Instrumentation is key to learning more about the conditions of the Mars atmosphere. Engineers attached an instrumentation system called MEDLEY to the heat shield of the Mars Science Laboratory. The system measured the temperature and pressure as the vehicle made its dangerous descent through the hot Martian atmosphere. MEDLEY provided engineers with invaluable data for future Mars missions. MEDLEY 2, which will fly on the next large Mars mission, Mars 2020, will go beyond the instrumentation on MSL and provide entry system data never before obtained on Mars. In addition to testing hardware in flight, there's plenty to research on the ground. Understanding how a spacecraft flies through the atmosphere is key to the entry, descent, and landing phase of any mission. Through advanced physics-based modeling and data gathering, engineers can use the information to enhance predictive capabilities and mature materials products for entry, descent, and landing technology.